Hello and welcome to the next session on time, speed and distance. Let us take the next question in continuation. Two trains start simultaneously towards each other from 2 points P and Q. They meet on the way at a certain point R. From here, both the trains continue in the same direction at their respective speeds to arrive at their destinations 16 and 9 hours respectively from point R. If the first train's speed is 120 km per hour, what is the speed of the second train? So as you can see, there are two trains that are being talked about, and they start from point P. The first one starts from point P. The second one starts from point Q, and they move in the opposite direction. Train T1 like this and train T2 like this, and they meet at a point, say R. R necessarily is not a midpoint, it is a point on the way to their respective destinations. It is said that after meeting at point R, they continue to travel in the same direction. So if train T1 was traveling in this direction, it met train T2 at point R, it continued in the direction of Q and reached Q at some point of time. Similarly, T2, which had started towards P from Q, met train T1 at point R, and from here it took some time to reach at point P. Now these times are given as 16 and 9. For train T1 after point R, it takes 16 hours to reach Q, and T2 from R till P takes 9 hours. Now let us start from the very basics of speed, time and distance. Train T1 till the meeting point, that is PR, it takes some time to reach R. Consider that time to be T. It is not mentioned here, so we'll take that time to be T. So the distance PR will be given by speed into time. This is the time. What is the speed of the first train? It is given as 120 km per hour. So 120 T. This value is 120 T. PR value is 120 T. Now, for train T2, it starts from point Q and reaches or meets train T1 at R. So it covers a distance QR. What is the distance QR? Distance QR will be speed into time. Time is same. They meet each other at time T. So time will be same. What is the speed of the second train? This is what is being asked in the question. So we'll assume that to be ST. Correct? Now let us see the next side of the picture. Train T1 after meeting at point R continues in Q direction and reaches the destination in 16 hours. So RQ will be given as speed of train T1 120 and the time taken. What is the time taken? Time taken is 16 hours. Similarly, for T2 train, it takes 9 hours to cover this distance from R to P. R to P. The distance will be given as speed of train T2, which is S we assumed, and the time taken, which is 9. So 9S is the time. Now this PR is same as this PR, right? And this RQ is same as this RQ. So you can equate each other. 120T is equal to 9S. This is what that we get from PR. And here After equating RQ, we get ST is equal to 120 into 16. Correct? We need S, the speed of the second train. So we take out the value of T here. T will be 9S by 120. And we place it here. In place of this T, we place 9S by 120 here. And this will be equal to 120 into 16. So essentially, you can write S square is equal to 120 square multiplied by 16 divided by 9. Or you can say S square by 120 square. 16 by 9. Okay, you can write it like this. S by 120 is equal to square root of 16 by 9. If you see carefully, S is the speed of train T2. S is the speed of train T2 and 120 is the speed of train T1, the first train. Okay, so essentially in place of S, if you write S2 to make it make sense as in speed of train 2, you can write S2 by S1 is equal to square root of T1 by T2. If you carefully see, 16 is the time taken by the first train to reach the point Q from R, from the meeting point, and 9 is the time that train T2 takes to reach P from R. So you can remember this shortcut. S2 by S1 is equal to square root of T1 by T2. Here what will be the value? This value will be S will be equal to 120 into 4 upon 3. This will be 40. So 160 km per hour. 160 km per hour is the speed of the second train. I hope you understand the entire logic. This is simply based on the formula of speed into time is equal to distance. From there we have got an expression which says the ratio of the speeds is equal to square root of the reciprocal of the time taken. Okay, and these times are nothing but the time taken by the respective trains to reach the destination from the meeting point. S2 by S1 is equal to square root of T1 by T2. I hope you understood it. In case you want to revise it again, you can replay the video. Let's take the next question. There are two trains running on two parallel tracks. Length of each train is 120 meter. When they are running in opposite directions, they cross each other in 4 seconds. And when they are running in the same direction, they cross in 12 seconds. What is the speed of the faster train? In the first case, the trains are moving in the opposite directions. So they cross each other. So train T1 and train T2. One train can be said to be crossing the other in this fashion. We can imagine that the train T1 has to not only cover the distance or the length of the train T2, not only this length, but it has to cover a distance which is equal to its own length as well. Okay, so you can imagine this to be like this. These are the two trains. Consider these points to be A dash and B dash B. Consider two trains to be like this. How can you say that the trains have crossed each other? When the positions become like this. A dash reaches here and A is here. again B dash reaches this point and B reaches this point. So essentially A dash moves this length, correct? This length is nothing but length of the train second, and B dash moves here, which is nothing but the length of the first train. Now here both the lengths are equal, which is 120 meters. Essentially what I meant to say here is when they are moving in the same, when they are moving in the opposite direction, the total distance covered is 120 by 120 plus 120. Okay. Thus time taken will be 120 plus 120 divided by the speed. The speeds here are not given. If you assume the speeds to be S1 and S2 and both of them are moving, you will have to take their relative speed. As you must be aware, since both of them are moving in the opposite directions, their speeds will be added to give the relative speed. That's why the time taken in this case will be 240 plus the relative speed, which is S1 plus S2. You can write 240 upon S1 plus S2, or S1 plus S2 is equal to 240 divided by the time taken. Time taken is 4 seconds. So this value will be 60 meter per second. Similarly, in the second case, where they are crossing each other in the same direction, which means that train T1, the faster one, overtakes the train T2. Here again, irrespective of the direction, you would realize that the train T1 has to cover the distance, cover the length of the second train plus its own length. Here also the total distance to be covered is 120 plus 120, the lengths of the two trains. And if you have to find out the time, then this time will be this distance divided by the speed. Since both of them are moving in the same direction, okay, the relative speed will be given by S1 minus S2, where S1 is the faster train, right? Only a faster train can catch up with another train. That's why the expression we will use is S1 minus S2 with an assumption that S1 is the faster train. So we write S1 minus S2. This time is given as 12 seconds. So you can equate this with 12. And you can write the equation as S1 minus S2 is equal to 240 by 12, and this is nothing but 20 meter per second. This is one equation and this is the other. From here we have to find out which is the fastest train, or what is the speed of the fastest train. As you realize, S1 plus S2 is given, S1 minus S2 is given. If you add them up, you will get 2S1, and that should be equal to 60 plus 20, that is 80, and S1 will be 40 meter per second. S1 will be 40 meter per second. The speeds are given in kilometer per hour here, so you need to convert this speed 40 meter per second into kilometer per hour, and to do that you need to multiply by 18 by 5. This will give you 8 into 18, or 144 kilometer per hour. So you should choose the option D for this question. I hope you understood the method. It is simple. When they are moving in the same direction or they are moving in the opposite direction, the total distance covered is 120 plus 120 in each of the cases. Okay, it doesn't matter which direction they are moving. The length to be covered will be the sum of the lengths of the two trains. Okay, and what will be the speeds? Since both the train are in motion, we'll have to talk about relative speed. If they are going in the opposite directions, relative speed will be sum of the speeds of the train